Good morning. Myself, Dr. Radhika, working as Assistant Professor in the Department of Agriculture Engineering, SNS College of Technology, Coimbatore. Last class, we discussed about the physical weathering of rocks. Today's class, we discussed about the chemical weathering. Chemical weathering, nothing but decomposition of rocks and minerals by various chemical process called chemical weathering, is an important process for soil formations. Then chemical weathering takes place mainly at the surface of rocks and minerals with the dip in certain mineral and the formation of secondary product new material chemical transfer. Suppose for example feldspar adding with water, it gives clay mineral soluble cations and anions. So weathering is an important process for the rocks and formation of rocks and minerals. So chemical process, there are so many processes are involved in the chemical process: hydration, hydrolysis, oxidation, reduction, carbonation, solution. Let's see the one by one. First process is hydration. Hydration is nothing but chemical combination of water molecule with a particular substance or mineral lead to a change in structure. Suppose a water molecule H2O is adding some of the particle or substance leading to a change in structure also. Soil forming minerals in rocks do not contain any water, undergo hydration when exposed to humid conditions. Upon hydration, there is swelling and increased volume of mineral. Suppose some substance is absorb the water, means automatically volume of mineral is increased. The mineral loses the luster and becomes soft. It is one of the most common process in nature and works with secondary minerals such as aluminum oxide, iron oxide mineral, and gypsum. These are the examples for the some examples for the hydrations. It's a very common and work in the secondary minerals such as aluminum oxide and iron oxide mineral. Let us see the one examples. Iron oxide Fe2O3, its another name is hematite. Hematite, then adding with hematite, otherwise red in color, it's adding with water H2O gives rise to limonite. It's Fe2O3 3H2O, it's yellow in color. Suppose the color of the particular mineral is also changed. Red color is adding with red color, some water molecules automatically change the yellow in color. So F2O3 adding with H2O, it gives rise to Ft2O3 3H2O, limonite, yellow in color. Then another example is aluminum oxide, bauxite, Al2O3 plus H2O gives rise to Al2O3 3H2O, hydroxide aluminum oxides. Then calcium sulfate anhydride, adding with water calcium sulfate 2H2O, it's a gypsum. It is one of the main factor for the application of alkaline soils. Gypsum is one of the important fertilizer for application of alkaline condition of soil. Then another example for magnesium oxide, iron oxide silicate, MgO, FeO, SiO2 adding with water gives rise to 3MgO 2SiO2 2H2O plus silicate SiO2 plus water molecule. Olivine is converted into serpentine. These are the main examples of hydration. Hydration is nothing but adding of water. For again I repeat, hematite Fe2O3 adding with water molecule, hematite is red in color. Suppose adding with water means it's converted into limonite, Fe2O3 3H2O, its color is changed yellow in color. Then bauxite. Bauxite is aluminum oxide, Al2O3 plus water molecule 3HOH gives rise to hydroxide aluminum oxide, Al2O3 3H2O. And then third one is calcium sulfate, CaSO4 plus 2H2O, unhydrated. Calcium sulfate is unhydrated. It's adding with water molecule gives rise to gypsum on calcium sulfate 2H2O. It is a water molecule adding with it forms a gypsum. It's mainly important fertilizer for the alkaline soils. Then last one is magnesium oxide, iron oxide silicate, olivine. It is called as olivine, MgO, magnesium oxide, iron oxide, iron FeO, silicate SiO2. It's adding with 2H2O. It gives rise to serpentine. 3 MgO plus 2 SiO2 silicate, 2H2O water plus silicate Si2 is separated, then water molecules also separated. These the factors, these are main examples for the hydration. These are the hydration process involved. These examples, main example for the hydrations of the weathering and rocks. So today's class we discuss about the hydrations class. Next class we have to discuss about the hydrolysis of weathering and rocks. Thank you one and all.